It's the Life Upfront Engineering Podcast. I'm your host, Jeff Waters, covering ideas, people, and products on the cutting edge of product development. As always, join the conversation at lifeupfront.com. On the show today, an electrical engineer who dares to offer advice on optimizing mechanical parts for mechanical engineers, a VP of Marketing and Chief Evangelist for SolidThinking's Inspire and I think also Evolve products, Tony Norton. Tony, welcome to the show.
Thanks very much, Jeff. That's quite the introduction.
So, I've talked about this area of topology optimization, which to let the cat out of the bag is a lot of what Inspire is about. I think it's so cool. It's this idea of taking a hard new look at the products that you make today. Maybe you've got a bracket that has looked the same for 30 years. But what if you could just go through and have the computer program look at the topology of that and optimize it and give you a shape that looks more organic, something that's more perfect, like a bone, like a human bone has evolved to have the perfect shape. So that's the area that you're in, and we're going to come back to that. But before we get to that, could you take us on your journey from being a double E in the UK and then working for something like 15 years for Altair in the world of stress and strain where us mechanical engineers live?
All right. Well, as you know, because you've spoken to me before, I have got a little bit of an accent. So I didn't start working in the US. I got my double E degree in the UK, and that's where I grew up. And I was working there. Actually, I did a little bit of electrical engineering before I stopped doing that, which was quite a long while ago. And then was doing some software development. Actually, the last bit of embedded software I did, so the last true bit of double E work was on in-cabin telephony. Do you remember the seatback phones on airplanes that no one ever used?
Yes.
Yeah, I worked on those. There you go. So the voice and tone board on that I worked on. So if it ever spoke to you, I had some part in that. Then after that, I worked at Ford for a little while, and then was working with Altair doing some project work there for Ford, and then that moved me over to the US. And after that, I did a number of different positions in our engineering services division at Altair, doing things as far apart, I guess, as development of torque vectoring axles, did some driver training in China. Let's see, I've worked on a commercial product, actually doing some electrical harness layout, and then also a big focus on the automotive world all the way through that. And then just at the start of the year, I took the position looking after marketing for our SolidThinking division.
So it's the whole division, which I believe is 3 products, SolidThinking itself, which the company's named after.
We got 2 products. So Altair acquired SolidThinking in 2008. And at the time, SolidThinking just had the one product, which was called SolidThinking. So it was the name of the company and the name of the product. That product now is SolidThinking Evolve, and then we have one other product, which is SolidThinking Inspire.
Oh, okay. So SolidThinking Evolve then is essentially a 3D modeling environment that's very free form, sort of gets you away from all the constraints of a history-based tool, a traditional CAD tool.
Yeah, it gets you away from the geometry constraints of traditional CAD tools, but it does still have history. So ordinarily, tools are either very good for organic surface modeling, but you don't have the history, or you can do geometric solids, typical solid modeling, and you have that history. So where Evolve shines is that it actually gives you that organic surface control, but gives you a construction history as well. So it's a hybrid modeler.
I got it. So I can see that, the whole market idea for SolidThinking, and actually I can understand why Altair would want to acquire the company. But I guess 2 questions. Why are they currently kept separate from Altair? Why is it not just rolled into Altair? And then secondly, why have this shape optimization FEA-based tool on the SolidThinking side of the house when that's really more the domain of Altair? Okay,
so Altair obviously has a number of divisions, Hyperworks clearly being the largest division of Altair. So Hyperworks tools are high-end CAE tools that are aimed at people who do simulation all day, every day. And SolidThinking, we have our two tools, like we've spoken about, Evolve and Inspire, both of which are aimed at design, or designers in general. So Evolve being more focused at concept design in the industrial domain and in industrial designers and architectural domain, and then Inspire, which also aimed at architects, but more design engineers. So neither group are CAE users. So that's why it's separated from Hyperworks. But due to the licensing model that Altair Hyperworks operates under, it allows you to use both the tools through that.
Okay, so if you are a hardcore CAE user, you're not left out in the cold. You could also get access to these tools.
Certainly, yeah. And as you say, with Inspire, we do have some OpDestruct users who find Inspire is really helpful for some of their early modeling.
So, okay, that brings up a really good point. Let's talk about OpDestruct because it's the most well-known of these shape optimization tools. At least it's the only one that I had heard of off the top of my head when you and I first chatted. So it's been around for a good while. It is a very high-end tool. It has a lot of capabilities, and it's, I think it's safe to say it's not for the faint of heart. You don't just put that in front of a non-specialist.
Yeah, very much. It was something that grew out of joint research for both orthopedics and mechanical engineering out of the University of Michigan. It came to Altair by some of the guys that were involved in that research, and yeah, it's definitely a high-end tool for people who operate at the very high end of simulation. So it has, like you say, has a lot of capability, but it's really a tool that you need to know your way around. And certainly folks like our guys in Altair Product Design, they know exactly what to do with it. A number of very high-end users in the aerospace and the automotive industry as well.
Yeah, let's just to make this very clear what we're talking about. I mean, I throw around this term topology optimization like my mother should understand what it means. So let's dive in just a little bit. Whether you're talking about OpDestruct or Inspire, what are we talking about here? Can you give some good examples of maybe where either has been used that people might recognize?
Okay, well, actually, maybe one good way of explaining it, because I've just got literally just before I came to talk to you, I just picked up the latest copy of Design World out of my mailbox, and Evan Yaris, one of the editors for Design World, has just written an article, and it's called "Structural Topology Optimization: The Opposite of FEA."
So I love Evan too. I'm going to put a link to this article in the note. He's a good man.
Maybe that might answer a couple of questions. So, pretty interesting because if you know much about the world of finite elements and you know what topology optimization is, you'll know that literally topology optimization is not the opposite of FEA, but figuratively and in terms of process, actually it is. And he makes a good point doing it. So ordinarily, if I'm doing finite element analysis, I'll design a part and then I'll pass that over to someone who's doing the simulation, or maybe I'll do the simulation myself and validate that part. I'll find out whether it's going to meet the stress requirements that I've set for that part. But if I'm going to do topology optimization, I'll start the other way around. I'll look at the loading that I'm required to meet. I'll look at the package space that's available to me. And then the topology optimization tool will generate a material layout that matches those requirements. And therefore, I know that I'm starting my design from a good footing. So now I use that as the input to my design. So instead of design being the input to my analysis is actually the input to my design. So that's kind of where I agree with Evan, that it is actually the opposite if you look at it figuratively and in a process sense.
So the process here might be that, you do have that bracket we were talking about earlier. It's connected clearly between 2 points. It's meant to hold two other objects together at these 2 points. So you know where the loading points are for whatever this bracket is, but you don't have a shape in mind yet for it. You just start with an amorphous blob, and then you tell the topology optimization algorithm to go through, look for areas of low stress and whittle them away, and keep doing that until you're left with something that might look like a human bone.
Yeah, you got it. Yeah, potentially it could look like a human bone. Often because of manufacturing constraints, that can't be realized. Although as we're seeing more and more additive manufacturing being applied, certainly in research groups, we are getting to see some of these more organic shapes that topology optimization will typically turn up without any controls being realized in hardware. And that's a real change that up to this point we've really had to control the results to make them fit the manufacturing processes available. And now with additive manufacturing, you're removing a lot of those manufacturing constraints, and you can really realize some of these extremely efficient structures.
Now, I have to say, as someone who really likes simplicity in software and the tools that I use myself, and this growing trend towards simplicity in products, actually being a must to win in today's market, FEA often doesn't really fall into that because it's just so difficult. There's so many things that have to go into it, and it's hard to make it slick and sophisticated. And, you don't have to look much farther than the GUI and see 30, 40, 50 buttons, options, windows in a typical product that you're going to have to learn your way around. So what caught my attention with SolidThinking first was, okay, I see about 5 buttons across the top of the screen.
Yeah, I think we maybe got a couple more. It's maybe a dozen, but it's not really that many icons running across the top. And that's really been the focus with Inspire, to make it give this functionality to the user in the most simple way possible. So one of the things that you probably noticed when you started using the tool was the fact that there's multiple functions within those icons. So there's not just a single piece of functionality, but we've grouped functionalities together inside of those multi-action sprites, as we call them. So as people move around, they know exactly where to look. And I think that was really key, is that we were taking something that was very complicated. Topology optimization certainly as a concept is very complicated, but the idea of shape generation as a concept really isn't. So we don't want to overcomplicate it there. We hid the meshing aspect from the user, because really where people are using this up front, they've got a good idea of their loads, they've got a rough estimate, they've got a rough idea of their package space. It's really just helping them through that concept stage. So it doesn't want to be a complicated tool. Also, the fact if someone is using CAD and that's their day in, day out tool, they don't want to relearn a new tool every time they need it. And so the idea is that someone can look at Inspire, they can pick it up very quickly. And if they don't use it for a couple of weeks, they come back to it, they know exactly where they're going straight away. So that was really important.
Well, let's talk about that key process flow. I mean, I think this is important. Your idea is to open a market of users that we could say currently don't exist for this kind of activity today. So they might be design engineers, at least here in the States. That's what we typically call a CAD user. Might have a mechanical engineering degree, might not. But they're doing the bulk of the 3D geometry generation for manufacturing companies here in the States, and probably in other parts of the world. That's about the same, I'd guess. Now you want to ask that person now to take on this added responsibility of doing, if you want to call it shape optimization or FEA or simulation, but it's something they're not doing today. And you see a lot of them, and you see a pent-up demand by them to do this. Or are they even aware of it? It's a lot of questions. Yeah.
All right. So I think I'll start with the first one. So, we're seeing, we are giving an extra tool to design engineers. There's definitely a need, and there's definitely a pull from design engineers for a tool that helps them design lighter parts, design parts faster. Also to help them understand their designs a little bit earlier on, because right now, if a design engineer creates their initial design and passes it on to the simulation group to validate it, and it comes back and they say, oh no, you're going to get hotspots here because you've got too much, we're seeing too much stress in this area. Then they're going to have to go back and rework it. If they can use a tool like Inspire very quickly to show them where material wants to be, that's going to cut down on those iterations. So I don't think we're adding work for them. We're moving some of that work up front, but kind of making them masters of their own destiny a little bit and understand why you want more material somewhere. So now they can play around with those loads, kind of understand more about the design. But like I said, not making it complex was important, and so being able to work within their preferred CAD tool to start off with, to sketch out the initial package space, which we generally call a design space in optimization terms. Apply the loads to that within Inspire, then they can create an initial optimization. They can look at that to see if there's any controlling of the result that they want with some manufacturing constraints. They can see a secondary result inside of Inspire, and then they can export that result straight back to their CAD tool and then refine it from there. So really, it's not a massive change in the workflow for a design engineer.
So once they get to the CAD tool, either with this exported, must be like a step file or an IGES file representation, right, or just eyeballing what they've learned visually, and then trying to include those ideas in their CAD drawing, their history-based CAD drawing. That's their next step, and they might be onion skinning over top of the step file to some degree too.
That's it. They'd export the result as an STL, and then they trace over it in their preferred CAD tool.
Okay. Well, so this whole concept of using CAE early in the process by casual users and non-specialists has always been near and dear to my heart. My listeners will know this. My readers know this about me. So I took a very complex idea, CFD, computational fluid dynamics, to market in the 90s and early 2000s. With this sole intention of putting it in the hands of design engineers. I mean, lots of other people have done this for FEA as well. You've got tools like, Mechanica and the old Cosmos tools, which I think are now SolidWorks Simulation, for example. So those tools are out there. And, I guess the lesson that I learned is there's a spectrum of ease of use that you need to really understand if you want to have widespread adoption. So you can make an FEA tool simpler than the standard status quo tool, right, and that will open you up to more engineers. There will be some design engineers who you've just passed their threshold of willingness to learn and use this tool. But I think that in most cases, the tools that I've seen out there didn't go far enough when you look at the spectrum ending at Twitter. So we go from, super hardcore PhDs are the only people who would even know how to press the open button on this thing, right, to Twitter, not to, 90% of the expert tool. And that's why I mentioned that you have so few buttons in this program. And that's the thing that that I have still yet to see in these upfront casual usage tools. I don't know if you've made it simpler enough or if the theory will even hold and that's enough to get over the threshold for widespread usage.
No, I think you've really hit on something. I think it is that speed of learning, because we spoke about the need for design engineers to work faster, but to work faster they don't want to stop what they're doing and learn something new. There's enough to learn when they get a new release of a CAD tool. They don't want to have to relearn for another task, basically. So no, the simplicity is key, and then our training. I mean, right now. Our formal training class is 4 hours long, and generally the last hour of that is looking at specific examples that the attendees brought along themselves. We've got many customers who literally just picked Inspire up and started using it, and they've watched maybe a couple of the tricks and tips videos that we've got on YouTube, and that's really up and got them going. So no, I think it is a key element to it. Actually, kind of another perhaps data point on that. Last week I was at the IDSA, conference. So that's the Industrial Designers Society of America. So these are folks. So these are folks that are more the classic Evolve customer. Yeah, these are people that probably most folks in the engineering realm, I think, are much more focused on appearance than they are on function. But they're kind of they definitely balance the two. But showing it to people at the IDSA, they were really intrigued by it because they saw it as a great tool for co-designing with mechanical engineers. So now the industrial designer can come up with what they feel the need is in the market, and they can work with the mechanical engineer to realize that, and they can use a tool like Inspire, which gives them a common language. Because if you start exploring something in a CAD design, then you start having to validate it in FE, and you get into those loops. There isn't really that common language that you're moving forward and developing it. So you don't get manufacturing involved. You don't get the industrial designer and the mechanical engineer involved at the same time.
Well, I see 2 objections coming your way. I imagine you're answering these on a pretty regular basis. One is, we are talking about at its root, a pretty complex solving algorithm under the hood. Mm-hmm. And you're putting that in the hands of non-specialists. So I know a lot of PhD experts out there who say that as soon as you do that, the world is bound to come to an end.
Yeah, those people are definitely out there. But the other thing is, like as we said, we're not trying to change the process within anyone's organization. So all of these designs that come out of the engineering design organization are still going to go through exactly the same validation process as they would have done anyway. So as more and more organizations are embracing the idea of bringing simulation up front, they're getting a better understanding of their loads earlier. They're certainly developing equivalent static loads when they have dynamic loads earlier. And so if you've got those, you might as well let your design engineers apply them as wait for them to produce their first design, and then let your simulation guys look at it.
Right. And so these early users, these casual users, then they're not exploring even the toughest of optimization areas. So this is all based on, in Inspire anyway, this is all based on linear static analysis. I don't think you include fatigue in that consideration either. Is that true?
Right, that's right. So we're just seeing straightforward linear statics. So yeah.
So the idea is that could be everybody needs to understand that can be a great first cut. And, once you get a little farther along in your development process, it will naturally end up in the hands of one of these experts who might be using something like OpDestruct.
Right, exactly. And I think even maybe these people who don't like the idea of such a tool being used early certainly see the issue with a tool like OpDestruct being used late. That by the time you've made a bunch of design decisions, now your opportunity to optimize is grossly reduced, because you can only optimize within the available package space, within the available design space to you. Whereas early on, you've got an opportunity to make some very different decisions.
Well, somebody on the OpDestruct team hates you right now.
No, it's good. It's all good.
All right. Well, then the second objection that I would expect, maybe you've addressed it already, is pricing. So, if you're looking, just step back, cross your eyes, and say, okay, we're putting a first level tool, a first cut, first pass style of tool in the hands of a non-specialist to do very, very early sort of at the concept work. Price could be an issue. Typically we're talking about $20,000, $30,000, $40,000, $50,000 for high-end FEA tools. And even if you try to chop that in half, that's often way too expensive for, hey, it's just part of my job, not my whole job.
Right. So there's 2 ways to buy Inspire. One is a paid-up license, which is less than $10,000, even for a server license, which can then be shared by a number of design engineers. Of course, the alternative that we spoke about a little bit at the start is current Hyperworks customers can run Inspire today via their Hyperworks units. So when you've got casual users using Inspire only here and there, potentially that's something they can do without any incremental cost.
And Inspire's a live product now. Somebody can come try it, buy it today. How long has it been around?
It's been around for the last couple of years. This current release 9.5 is actually the second release as Inspire. We used to have it as a module of the old SolidThinking product before that became Evolve, but it's a product of its own for the last couple of years.
Good.
But of course, underneath it's based on OpDestruct, which, like you say, has been around for 20 years. So that it's got a good foundation.
All right. Well, if my listeners want to learn more about Inspire, where should they go? I mean, you must have video gallery, lots of white papers or information they can find. What are the best web resources for that? And then we'll wrap up with the best way to get a hold of you if they want to contact you directly.
Okay. So they can go to solidthinking.com. And actually, if you go to solidthinking.com/inspire95, there's a nice summary with an introductory video and the new features in 9.5. And then also there's a 30-minute webinar recording that gives you a great introduction. So that's solidthinking.com/inspire95. We also have a YouTube channel. So the SolidThinking YouTube channel, which has a large number of videos on. And we're on Facebook and Twitter if you want to get the latest news as to what we're up to.
Great. Tony, I appreciate you coming on the show today and sharing a little bit about Evolve, Inspire, SolidThinking. You at least fixed one problem. I thought SolidThinking was the CAD tool still, but it's Evolve.
Well, I'm glad I cleared that up, if nothing else.
And I'll be tracking your success, hopefully, and progress out there, trying to get upfront engineers doing more upfront analysis.
That's great. Thanks very much, Jeff. Appreciate the opportunity.
That's all for this episode. Thanks for listening to the Life Upfront Engineering Podcast. Visit lifeupfront.com to comment and connect with me on Twitter, Google+, and LinkedIn. Also, you can really help the show by leaving a review on iTunes. Thanks again. Until next time.